We're doing an overview from systemsarchitect.io. This is 15 AWS EC2 strategies, part 1. We broke this up into 2 parts because there were so many. Subscribe to the channel and like this video for more great tips. Amazon Elastic Compute Cloud, EC2, gives you enormous control over cost, performance, and security. Almost all of it sits behind settings people accept without reading. EC2 is where most AWS builds go to die. It is also where most reliability problems start. A wrong-sized instance fails quietly for months. So does one left unmonitored or wide open to the internet. Teams that run EC2 well are not smarter than everyone else. They just made deliberate choices the console never asks about. This is part 1, covering 15 strategies. We go from right-sizing and purchase commitments through load balancing, backup, monitoring, and spend tracking. 15 AWS EC2 strategies, part 1. 1. Right-size instances continuously. 2. Implement auto-scaling groups. 3. Use spot instances for flexible workloads. 4. Purchase reserved instances for predictable workloads. 5. Use savings plans for flexible commitments. 6. Distribute traffic with elastic load balancing. 7. Share file storage with Amazon EFS. 8. Enable instance hibernation. 9. Control traffic with security groups and network ACLs. 10. Backup with AMIs and Snapshots. 11. Monitor and log with Amazon CloudWatch. 12. Assign IAM roles and policies. 13. Use elastic IPs for stable addressing. 14. Use placement groups for performance. 15. Track spend with cost management tools. 1. Right-size instances continuously. Right-sizing means matching the instance to what the workload actually consumes. It is the single largest source of avoidable EC2 spend. Most instances are picked once and never revisited. The result is a fleet where CPU sits in single digits. AWS Compute Optimizer is the primary native tool for this. It reads real usage history and recommends specific instance types. CloudWatch covers CPU and network, but memory and disk need the agent. Treat right-sizing as a monthly review, not a one-time cleanup. 2. Implement auto-scaling groups. An auto-scaling group manages a fleet as a single unit. It adds capacity when demand rises and removes it when demand falls. The bigger win is availability. The group health checks its instances and replaces any that fail. Spread it across multiple availability zones and a whole zone can go down. Target tracking is the right default for most teams. You name a metric and AWS holds it steady. Keep instances stateless so any one of them can be terminated. 3. Use spot instances for flexible workloads. Spot instances sell you spare EC2 capacity at a steep discount. Savings commonly run 70 to 90% off on demand. There is one condition. AWS can reclaim the instance with a 2-minute warning. That trade is unacceptable for a payment API. It is close to free money for batch jobs, CI runners, rendering, and stateless workers. Checkpoint long jobs so work resumes instead of restarting. Diversify across instance types and zones so one shortage cannot drain your fleet. 4. Purchase reserved instances for predictable workloads. A reserved instance is a billing commitment, not a different server. You agree to a 1-year or 3-year term in one region. The discount reaches roughly 72% at the 3-year all-up front end. Nothing changes about how the instance runs. Unused commitment is money burned. Base it on your steady-state floor from the last several months, never your peak. Set a reminder before expiry, because lapsed reservations revert to full price. 5. Use savings plans for flexible commitments. What if you never had to pick an instance type? Savings plans let you commit to a fixed amount of hourly compute spend instead. AWS applies the discount automatically to whatever matching usage you run. There are two flavors. Compute savings plans span families, sizes, regions, and even Fargate and Lambda. EC2 instance savings plans lock to one family in one region and pay out deeper. Size the commitment with AWS Cost Explorer and commit slightly below your floor. 6. Distribute traffic with elastic load balancing. A load balancer spreads incoming requests across your instances. That is what turns a group of servers into a system that survives losing one. It health checks its own targets and pulls failures out automatically. New instances from an auto-scaling group register themselves. Application Load Balancer works at the HTTP layer with path and host routing. Network Load Balancer works at TCP and UDP for extreme throughput. Terminate TLS with a certificate from AWS Certificate Manager, which renews it for you. 7. Share file storage with Amazon EFS. Why not just use a disk? Why not? An EBS volume attaches to one instance in one zone. Amazon Elastic File System is a managed NFS file system many instances mount at once. The same files stay visible across every zone. It grows and shrinks on its own, so there is no capacity to provision. Content systems, shared media, and web fleets behind a load balancer all fit. Content per operation is higher than local block storage, so keep databases on EBS. 8. Enable instance hibernation. Hibernation stops an instance the way closing a laptop lid does. Memory is written to the encrypted root EBS volume. Start it again and processes and warm caches come back exactly as they were. A normal stop and start loses all of that. The payoff is largest for slow-starting apps and developer environments. Hibernation must be enabled at launch, and support is limited to specific families and sizes. You pay no instance hours while hibernated, but storage still bills. This comes from systemsarchitect.io. See the full section there. Also be sure to like the video and subscribe to the channel for more and check the video notes for links. 9. Control traffic with security groups and network ACLs. Security groups are stateful firewalls on an instance's network interface. They hold allow rules only, and return traffic is permitted automatically. Network ACLs sit at the subnet boundary, are stateless, and support explicit deny. That makes them the right place to block an address range subnet-wide. Reference other security groups instead of IP ranges. The rule then stays correct as instances come and go, which flat CIDR blocks never do. Never leave SSH or RDP open to the entire internet. Use AWS Systems Manager Session Manager for shell access instead. 10. Backup with AMIs and Snapshots. An Amazon machine image captures the whole instance for relaunch. EBS snapshots capture individual volumes incrementally into Amazon S3. Only changed blocks are stored, so cost and backup time stay low. Automate it with Amazon Data Lifecycle Manager or AWS Backup. Both run on tag-driven schedules with cross-region copies for disaster recovery. Set retention so old snapshots expire on their own. An untested backup is a hypothesis, not a recovery plan. 11. Monitor and log with Amazon CloudWatch. CloudWatch collects metrics from every instance automatically. The default set is narrower than people assume. CPU, network, and disk I/O are there out of the box. Memory and file system space are not, because the hypervisor cannot see inside the guest. So why install an agent? The CloudWatch agent closes that gap. Ship logs to CloudWatch logs so they survive the instance that made them. Alarm on the metrics that predict user-visible failure and route them to an SNS topic your on-call sees. Enable 1-minute detailed monitoring in production. 12. Assign IAM roles and policies. An IAM role gives an instance temporary rotating credentials. That replaces long-lived access keys baked into config files. Those keys leak because they end up in images, in source control, and in logs. Scope each role to that one workload, not to what is convenient. Use separate roles per tier so a front-end compromise cannot reach the database. Require IMDS version 2, which closes the request forgery path used to steal credentials. Keep passwords in AWS Secrets Manager and let the role reach them. 13. Use elastic IPs for stable addressing. An elastic IP is a static public address you can remap between instances. A default public IP changes every time an instance stops and starts. A fixed address matters for partners who allow ListView and for failover. Use them sparingly, though. AWS bills an hourly rate for every public IP version 4 address, attached or idle. Orphaned addresses become mystery line items on the bill. Most architectures need none. Private subnets, a load balancer, a NAT gateway, and Route 53. 14. Use placement groups for performance. A placement group tells EC2 how to physically position your instances. There are 3 strategies. Cluster packs them together in one zone for the lowest latency. That is what high-performance computing and tightly coupled simulations need. Spread puts each instance on distinct hardware, so one failure cannot take 2 down. Partition splits the group into separate failure domains, built for Cassandra, Kafka, and HDFS. A cluster group concentrates all your risk in one zone. 15. Track spend with cost management tools. You cannot optimize spend you cannot see. A default bill hides everything behind one large compute number. AWS Cost Explorer breaks it open by instance type, region, account, and tag. That last one depends on tagging discipline. Agree on owner, environment, and application, then enforce them with AWS config rules. Set AWS budgets alerts on both actual and forecasted spend. Turn on coverage reports and cost anomaly detection to catch jumps automatically. In summary, EC2 gives you far more control than the launch wizard suggests. Get sizing and scaling right first. Right sizing, auto scaling, and load balancing fix idle cost and fragile fleets together. Then layer the purchasing model on top. Reserved instances and savings plans cover your steady floor. Spot instances serve everything flexible at a fraction of the price. Protect it with tight security groups, least privilege IAM roles, and tested backups. None of the savings matter after a breach or a failed restore. Keep visibility through CloudWatch on the operations side and Cost Explorer on the financial side. Problems then surface as alerts rather than surprises. This was part 1, and part 2 continues with the next set of EC2 strategies. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.